Hello there, welcome to Csec Math TV. Today we'll be looking at matrices. Nice. So consider this activity below. Complete the table by stating how many of each item is in your home, your uncle's home, and your best friend home. So pause the video and complete that table. So for me, I have one bed, one table, and two chairs in my home. My uncle has 3 beds, 2 tables, and 6 chairs. My best friend has 2 beds, 1 table, and 4 chairs. Now, the horizontal lines in the table, the horizontal lines, persons, myself, uncle, best friend going across, those are known as rows. And the vertical lines at the top, persons, number of beds, number of tables, number of chairs, going downwards, those are known as columns. Alright? Hey! So look at this now. What if we were to rewrite this table without the heading of the table? So we're going to rewrite this table by remove the headings and also place a square bracket around the numbers. When we do so, this is known as a matrix. This is known as a matrix. That's all a matrix is. So a matrix is defined as a rectangular array of numbers or letters consisting of rows and columns. Examples: 1 1 2 3 1 4 2 7 2, 3 2 minus 5 2 1 3, A B C D E F minus Q R. Now from all these examples, what do you notice? Well, what we should notice is that the number of rows and columns of each is different. Look at example 1. Let's call this matrix A. 1 1 2 3 1 4 2 7 2. What do we notice? The number of rows is 1 row, 2 row, 3 rows. The number of columns is 1 column, 2 column, 3 column. So the number of rows is 3 and the number of columns is 3. Now, the order of a matrix is the size of the matrix, and it is written as the number of rows by columns. Now, this matrix had 3 rows and 3 columns. So from example 1, we can conclude that the order of matrix A is 3 by 3. Now, using that same principle, what would be the order of matrix B? So we see that matrix B has 2 rows and 3 columns. And so the order of matrix B is 2 by 3. Let's try another one. What is the order of matrix P? So matrix P has 2 rows and 2 columns. And so the order of matrix P is 2 by 2. Let's do 2 more. Example 4. What is the order of matrix Q? Now we see that Q has 2 rows but just 1 single column. So the order of Q is 2 by 1. What's the order of matrix J? J has 1 row but 2 columns. So the order of matrix J is 1 by 2. The next thing we're going to look at is the types of matrices. Now there are 4 types that we really need to consider for Csec mathematics in particular. We have column matrix, null matrix, square matrix, and row matrix. Let's start with the column matrix. The column matrix, this is a matrix with 1 single column. It just has 1 1 1, only 1 column. So examples, the matrix A, 4 2 1. As you can see, it has 3 rows but 1 column. So the order of matrix A is 3 by 1. So it's a column matrix. B is minus 5 2. So the order of matrix B is 2 row but 1 column. So it's 2 by 1. Now anytime it has just 1 single column, it's a column matrix because the column is just 1. The next thing to look at is row matrix. The row matrix is just like the column matrix, single column. Row matrix means single row. And so the order of the matrix A in this example, 2 13 1, is going to be 1 row but 3 columns. So it's 1 by 3. The order of matrix B, 1 row but 2 columns. So the order of B is 1 by 2. The next type of matrix is known as a square matrix. Now the square matrix, this is a matrix with the same number of rows and columns. So it just have the same number of rows and columns. Example A, which is 2, 7, 1, 4. The order of A is 2 by 2 because it has 2 rows and 2 columns. B, 4 minus 1, 2, 2, 5, 0, 6, 5, 1. The order of B is 3 by 3 because why? It has 3 rows and 3 columns. Nice. The next one to look at is null matrix. This is a square matrix where all the elements are 0. Example A, 0, 0, 0. It is of course a 2 by 2 and all the elements are 0. Now it have to be a 2 by 2. So B in this case, 0, 0, 0, 0, 0, 0, 0. The order of B is 3 by 3 and so this is also a null matrix. Now look at this example, 0, 0, 0. This is not a null matrix. Can you tell me why? It is not a null matrix. Why? Because the order is 3 by 1. But the definition of a null matrix states that it has to be a square matrix first and then all the elements have to be 0. Alright? So now we're going to look at computations of matrices and we're starting with the basics, of course, addition and subtraction. So what are the rules when we talk about addition? Now in order to add or subtract two matrices, they must be of the same order. That's the first thing. We highlight it in red. It has to be of the same order. Now when two matrices A and B are of the same order, we call these conformable matrices. So in other words, to add two or subtract two matrices, they must be conformable matrix. Finally, to add or subtract two conformable matrices, we add or subtract their corresponding elements. Now the best way to do it is with examples. So given the matrices A, B, C, and D, determine A plus B, A plus C, A plus D, and C plus D. Let's do these examples. Let's start by doing A plus B. So part 1, A plus B. The matrix A is negative 1, 2, 0, 5 plus matrix B is 2, 7, 0, 1. Now we're going to add the corresponding elements. The negative 1 and the 2, they're in the same position. So we add the negative 1 plus the 2. And then the 2 and the 7, those are in the same position. So we add the 2 plus the 7. The 0 plus 0, we add those because those are in the same position. And we add the 5 plus the 1. So what we get for the result matrix is 1906. Alright, now we could have added A plus B because why? A and B were both two matrices that were conformable. Now let's add A plus C. Matrix A plus matrix C, minus 1, 2, 0, 5 plus 2, 5, 11, 0, 2, 3. Now, this has no answer. Why? Because matrix A is a 2 by 2 and matrix C is a 2 by 3. So A and C are non-conformable matrices because they do not have the same order. Let's look at A plus D. Again, matrix A is a 2 by 2 and matrix D is a 2 by 3. So automatically we cannot add them because they are non-conformable matrices. So let's look at C plus D now. Now C is a 2 by 3 and D is a 2 by 3. So we can add them. So we add the corresponding elements, 2 plus 5 to give us 7, 5 plus 4 to give us 9, 11 plus 9 to give us 20, 0 plus 0 to give us 0, 2 plus negative 4 to give us negative 2, and 3 plus 2 to give us 5. Notice we add elements that are corresponding in both matrices. Nice. Now what if you were subtracting? So given the same matrices, let's do the subtraction now. If we wanted to find matrix A minus B, we subtract the corresponding element. So it's minus 1 minus 2, and that's minus 3. Then 2 minus 7, that's minus 5. 0 minus 0, that's 0. And 5 minus 1, that's 4. So A minus B is negative 3, negative 5, 0, 4. Now what if we wanted to find A minus C? Now A minus C, that would be negative 1, 2, 0, 5 minus 2, 5, 11, 0, 2, 3. But that has no answer. It has no answer because A and C are non-conformable matrices since they're not of the same order. What about A minus D? Well, likewise, we cannot find A minus D. We cannot find A minus D because they are non-conformable matrices. Alright? Now let's have a look at C minus D. To compute C minus D, it's both 2 by 3. So we're going to subtract corresponding elements. 2 minus 5, which is negative 3. 5 minus 4, which is 1. 11 minus 9, which is 2. 0 minus 0, which is 0. 2 minus minus 4, which is 6. And 3 minus 2, which is positive 1. And that's how we subtract two matrices. Alright? So just to refresh our memory, first thing we have to remember that a matrix is just a rectangular array of numbers or letters. Alright, that's all a matrix is, and we need to remember that in order to add or subtract two matrices, they have to be conformable, meaning they're of the same order. The types of matrices are column matrix, row matrix, square matrix, and null matrix. So that summarizes the video. So that's it for today. So stay tuned to CXC Math TV for more, and do have a wonderful day.